we finished our slide and all the part. I think we all finished it, and we can present this time.
Okay, very good.
Should we start now?
Yeah. Go ahead.
Okay.
Yeah, whenever you're ready. It looks frozen, yeah? It looks frozen. Yeah, try to reshare. Try to reshare. I'm sure. Try to reshare. Yeah, let me share the documents that we're using meanwhile, just for the people that are here. Oop. Some technical difficulty, guys. Yeah, tell me, meanwhile, just tell me how many people were in the group. It should be, let me check, group A. You should be 4 people, correct?
No, we have 6 people in the group.
Okay, good. Group A, 6. Let me check if it's consistent with what we have. Oh, yeah, you're right. Sorry, I didn't scroll back. Yeah, you guys are 6 members. Okay, very good. Attempt number 2. Let's hope that this one goes. Okay, very good. I can see Canva, yeah? Can make, yeah. Yeah. Are you okay? Are you okay? I don't know what is happening. Guys, is it my connection or? Hello. Guys, is it my connection or?
Hello.
Hello.
Okay. Okay, so for the challenge 0, we is just discuss the exploratory and trend analysis. And next page. This is an overview of our data sets. We acquire our data sets from Kaggle. Next, the data sets consist of substantial 114,000 data points. Each song in this data set is described by 20 different audio features. These features range from popularity and duration to danceability and energy. By the way, there are 3 missing values within the dataset.
Yeah, out of 100,000 points, I think it's okay. Yeah. Can you click hide on the Google Meet tab, please, so that we can see better the slides? Yes, exactly. Good. Go ahead.
Okay, next page. Okay, as into the visualization on the distribution of song popularity. You notice that a significant portion of the songs, about 20%, have a popularity score of 0. This suggests that these tracks might be less familiar to the general audience, possibly due to limited exposure. And when we exclude the zeros, we find peaks around scores of 20 and 40. The average popularity stands at about 33, highlighting that most tracks are relatively obscure, with only a few achieving significant popularity. Okay, next page. In this slide, we are into danceability. This term refers to how well a song might inspire dancing or physical movement. Danceability is measured on a scale from 0 to 1. Songs that are closer to 1 are highly danceable, such as disco or pop music. These genres are known for their upbeat tempos and rhythms. On the other hand, songs with a danceability score closer to 0, like symphonies or free jazz, might not be the first choice for a dance. These styles often have a different composition that focus on other musical elements rather than a danceable beat. Our datasets reveal an average danceability score of 0.57. This indicates that while there are certainly some songs that are highly danceable, and some that are not at all, most of the music falls somewhere in the middle range. Okay, next page.
Let me ask you, how do you think they generated this this feature? How do you think they generated it? How would you measure? You know what I mean? How would you measure danceability? It's not human. Yeah, you think it's
tempo like that.
But it must be something else, right? Maybe it's a function of tempo and yeah. Because I mean, you can never. Yeah, I think it's not only tempo, right? It must be something else. But do you think they have some human labeling as well? Do you think that they ask some people to rate the danceability?
I guess they have a formula and use some values like tempo or whatever to calculate this score.
Yeah, it's not a deep model for sure. Yeah. Go ahead.
Okay. This is the tempo distribution in the data set. The highest bar, which indicates the most common tempo, falls between 120 and 130 beats per minute, with an average tempo of 122 BPM. This tempo range is particularly characteristic of pop music. Next, notice a hill around 90 to 100 BPM. This tempo is frequently found in genres such as hip-hop or R&B. And there is a smaller hill around 170 to 180 BPM, which might include fast-paced rock or drum and bass. These genres utilize higher tempos to create energetic or intense listening experience. And a small hill around 70 to 80 is typically a slower ballad, offering a more relaxed and emotional atmosphere. Okay, next page. For data about the top artists and genres in our data set, we can see that the Beatles led the way with about 280 songs. As for genres, we found that our dataset is especially organized, with the top 10 categories each offering neat 1,000 songs. Okay, that's for my part.
So now we come into part 2. So which focus on temporal trend analysis. Our goal was to look at how this dataset of 114 songs had evolved over the time, especially
Can I ask you about the title of the slides? Analysis action is I don't know the English word.
Oh, I think it's a typo. My bad. It's a temporal trend analysis.
Okay, analysis. The
yeah.
accent is on the last syllable. Go ahead.
Okay, my bad. Okay, so
No matter.
specifically looking at the stylistic and popularity shift from the 1990s through the 2020s. This set the stage for understanding the historical context of the music before we dive into the chart success and machine learning. Next slide, please.
No, wait a second. Look at the
okay.
Go back one second. So because look at the right plot. So the number of songs released per year is very it's very regular, right? It's suspiciously regular. So yeah, I wonder why it is so regular. But look at the popularity, right? So if I look at the popularity, I think so what can we say here? Because the year on the right plot, right, is the release year. That's why you have songs from the 1900, right?
Yes.
And then it seems to me, right, if I look at it like this, that the left-hand side of the plot has much higher variance than the right-hand side of the plot. Do we agree?
Yes.
And I think it's because, right, on the left side of the plot, you have very few listeners that give a score to the song, or they listen to the songs. And the right-hand side, they have much more listeners. So when you do the averaging of the popularity, it's more stable on the right and less stable on the left, right? Because who goes and listens to a songs from the 1990s, right? So it's probably there is some effect there. Do you understand what I mean? Do you agree?
Yes.
Because you have to imagine that the website probably opened in the 1990s, something like that, and then the number of users increased. So probably there is a bias toward the earlier tracks. But why is the release? Why the song count is so regular? You think? I wonder. Okay, very good. Go ahead.
Oh, okay. So the next part is we analyze is the music getting heavier or faster? So one of the core question in level 2. And based on our audio feature tracking, we can see a clear trend in features like tempo and balance. Interestingly, while we might expect music to get happier as production become more accessible, the data actually help us identify if modern music is becoming more melancholic, if the TikTok era is driving up the danceability of recent track. So here's the 3 line. It's red one is for tempo, the green is for danceability, and the purple line is for valence, the happiness while listening to the song. Next slide.
Oh, wait.
Oh, okay.
Let me appreciate. Let me appreciate. So because you see that the happiness and the tempo, right, they are correlated, right?
Oh yeah.
So you see that so there is a positive correlation in the 1990s, right? And then when the tempo drops, also the happiness drops in the below 2010, right? So there must be some love ballad time. And then there is a peak in the 2015 when both the mood and the tempo increase. then there is an anti-peak, right? There is a reverse peak in the 2018 or something. So it seems that there are different genera, right? So that, like, it seems that there is a latent variable, right? Which is the genera.
Oh, yeah.
And the genera decides whether the peaks are positively correlated or negatively correlated, right? You can have a very fast song, which is very sad. You can have a very slow song, which is very happy. And this depends on the specific genre, I think. Okay, go ahead. Very nice.
Next slide. So the slide 3 is about comparison of the eras. So when we group the data into decades, like the 19, the 2000, the 2010s, and the 2020s, we see a distinct stylish shift. So this box plot show how popularity and energy distribution have changed. For instance, we can observe whether newer music has a more standardized sound with less variant in energy, or if the 1990 track still maintain a unique profile in today's streaming landscape.
Can I tell you this plot is not clear at all? Can I be honest? Because look at the lines, you see how difficult it is to see a variation, right?
Oh,
because the so can you explain the box plot to everybody? Like, what do you see here?
Okay.
So you have the dots. What are the dots?
Wait.
I can help you, of course. I mean, I can help you. But look at let's take the plot on the right. You see that there are those dots. You know what those dots represent?
Let me check my.
Again, I don't want to torture you, right? So I just ask you, if you can explain it, you explain it. Otherwise, I'll help you. Tell me if you need help, huh? He's still
I think Nick help.
So the plot is there to sort of represent how spread out the distribution is. Okay, so in the plot you have the dots that are either, you see on the right plot, right? There are those dots. Those dots can be either below or above the bar, and this represents the outliers of the distribution. So a distribution as a mean, as a median, as a variance, and whatever lays like more than 3 sigma, 3 times the standard deviation away from the mean, is considered to be an outlier. Okay. Then you have that you see that the thin line, the thin black line, that's usually the 90th percentile. So it tells you that 90% of the data lies in this. And then you have the box that goes from minus sigma to plus sigma, and the line is the median or the distribution. So if the black line is close to the middle of the box, then it means that the median is very close to the mean. So it means that the distribution is roughly symmetric. Okay, and then again, if the box is it's close to the center, it means that the distribution again it's very symmetric, right? Because let's say 45% of the data is on the left and 45% of the data is on the right. Okay, so you see that here the issue is as follows. You have a lot of scores which are close to 0, and these are all outliers. And then the danceability, it's a score between 0 and 1. So even if there is a change, right, the change is always around this 0.58, whatever. And the variation from year to year is too small in terms of median or in terms of mean to be seen, so that those lines, they all look straight. So in your final report, please just change the representation, right? So that it's clear to see the difference. Because from the naked eye, here I don't see any difference in the distribution. Okay?
Okay.
You understand my point, right?
Okay, yes.
Very good. But you can see, for example, that the popularity, you see, okay, the popularity, let's look at the popularity plot. You see that the box plot is telling you that the popularity is very spread out, but the mean and the median they're very different because the tail has a very long distribution because the box is close to the bottom. So it's telling you that the distribution is centered on these low values, and then that skews up the median to be a little bit away from the mid. Go ahead.
Okay. Next slide. We look at how specific genres interact with these features. So while pop and K-pop show high energy and danceability as expected, we found a paradox in the data. The sad genre actually has a very high average danceability score. This suggests that the modern melancholic music often use rhythmic, danceable beat, which is the key insight for understanding what make a genre popular today.
Let me parse this, right? So grunge has a lot of energy but very low danceability. That makes a lot of sense. Then anime, emo, what the? You said K-pop, right? What is K-pop? K-pop is there. K-pop has a very high energy, a high very danceability, and a very high mood. It's nice. It's nice. And pop, good. Okay, very nice. Go ahead.
Next slide. To wrap up, there's two important limitations to keep in mind. First is the popularity score at a current snapshot and don't represent a song's success at its original release date. Second, as our initial data set lack release date, release year, these temporal trends current use simulate date. Our next step as the team is to merge this with the Spotify top 200 chart data to validate this finding with real-world chart position. So we're moving on to the next part.
Excellent. Excellent.
Okay, so in my part, I merged the Spotify tracks dataset with the Spotify top 200 chart dataset. And the goal is to understand three aspects. First, which songs have appeared on the chart. And second, how charted songs differ from non-charted songs in terms of audio features. And the third is how songs perform on the charts, such as peak length and chart duration. Okay, so before merging the datasets, we first perform data processing. And I standardize the track and artist names by converting them to lowercase and removing special characters and feed information. And then I created a merge key by combining the clean track name and artist name. Using this key.
Can I ask you something? So there is also a track ID. So the track ID between the two datasets is not the same, or they're not aligned per track ID?
You mean the data is different?
Yeah. So the two datasets, they don't. Because both datasets are from Spotify, right?
I download two datasets, and one is track and another is chart.
Yeah, but so both datasets, they should have a track ID which is unique. And is the track ID the same between the two datasets or not? That's what I see. That's why you have to do this. Okay, understood. Yeah. Okay, very good. Go ahead.
Okay. So the key, using the key, we merged the Spotify tracks dataset with the chart dataset and identified which songs had appeared on the chart.
Understood.
And during the data processing, I encountered an issue with the size of the Spotify chart dataset, and which is extremely large. So to avoid slow computation and memory limitations, I filter the dataset to keep only the global chart.
Okay.
And next, we compare the audio features between charted and non-charted songs.
Let me ask you a second. After you do the merging of the two datasets, how many songs do you have in the dataset with the matching chart information?
I'm not sure how many the data is left after the global chart.
But let's say you have, let's say, 100,000 in the so I want to know this, right? So the dataset, the Spotify dataset, it's 100,000. How big is the charted dataset?
It's like almost 1 GB, I think.
One?
1 gigabyte.
No, but how many songs in that 1 gigabyte? It's like,
I'm not sure. Maybe I should check.
yeah, check it. I just want to know because depending on how much data you have, right? I can understand what is the variance of the data. That's my concern. Oh, look at Claude. We can see everything that he's doing. Yeah. Okay, Google Drive. The Spotify chart, Google Lab. Very nice. You guys worked on the same collab, right?
Oh yes, but this one is I paste another one for my part, so there's no others in this one.
Understood. Okay. So the other one is 200. Whoa, 2 million. Okay, 2 million. Okay. And when you merge them,
and after
missing intermittent charts. Clean. Chart summary. Merge. Okay. Merged.
Oh, I think it's like here.
Okay. Merge shape 100,000. Charted songs 6,000. No, yeah, 6,000. Non-charted songs 10,000. So charted ratio. Okay, that's okay. So we have 6,000 charted song. Tell me if my question makes sense, right? You do not know, right? If all the uncharted songs. Okay, let me rephrase the question. If you take the different, no, stay there on the code, If you take all the charted songs that you have merged, okay?
Oh, yeah.
And you subtract from the charted songs in the database, right? Is it possible there are some charted songs in the Spotify dataset that you were using that you were not able to match with the charted dataset because, let's say, the keys were not correct?
You mean is repeating or?
And I know, for example, because you created the key, right?
Oh, yes.
Using the name of the artist and so on and so forth. Let's say that the artist had a middle name. Let's say John B. McCarthy. And in the other data set, the middle name was not recorded, so it was only John McCarthy. So when you merge the keys, there was an error in merging the keys. That's possible, right?
Oh, yes.
Okay, good. Just to understand. Because that's why I was asking for the track ID, because I don't know if there is a unique track ID. Because, of course, maybe there are some differences in the way the title of the song is recorded, or yeah, just wondering. Okay, go ahead.
Okay.
So we have 6,000 charted and 10,000 uncharted, but the 10,000 uncharted, okay, go ahead.
Okay, so we compare the audio features between charted and non-charted songs. And from the figure, we can see that charted songs generally have higher popularity scores. And they also tend to show slightly higher energy and danceability compared to non-charted songs. This suggested that songs appearing on a chart may have stronger rhythmic or energetic characteristics.
Yeah, stay there a second. Go back a second. So so popularity, density, energy, and so on, they are all in the range between 0 and 1, correct?
Yes.
But the tempo is between 0 and 1,000, correct?
Mm,
No, I'm going somewhere. You agree, right?
yes.
So the issue here with the plot that you have is that the features have different ranges, right? So when you plot the tempo difference, right, then it's a much larger difference. So my suggestion is that when you do the final report, you normalize the difference. So instead of doing the difference as an absolute difference, you do the relative difference. So you take difference of charted minus difference of uncharted divided by the range of the variable. Okay?
Okay.
So that they are all on the same scale. Because otherwise you see here that there is a small, you say that there is a small difference in densability, but that's only because you haven't normalized the difference, right? Because the densability is between 0 and 1. So it could be the one is densability 0.1 and the other was a densability 0.9. The difference is 0.8 and it looks small here because the tempo has a much larger support. Okay?
Okay.
Good. So now tell me why the popularity goes beyond 1. Because the popularity should be between 0 and 1, correct?
Popularity. I think popularity should be.
Okay, good. Okay, understood. Okay, go ahead.
Okay.
Double check this, please. Always divide by the support. Okay, go ahead.
Okay, so and we also analyze how songs perform on the chart. The figure shows a distribution of peak ranks and the number of weeks songs stay on the chart. So we can observe that some songs reach a very high rank quickly but stay on the chart for a shorter time. Others may not reach the very top but remain on the chart for many weeks.
Wait. Let me ask you this. So chart performance. So this is the distribution of the peak rank. Okay, so for each song, you see how long they were in the chart for, and you put the maximum of that chart. So where do you see the duration? Where do you see the? Repeat to me. So this is the peak rank, right? And you see how many songs have a certain peak rank. So where do you see the information on the week, the number of weeks they were in the chart?
I think maybe I forgot to put another chart.
Okay, yeah, it's the next plot. It's this one. Week of charts.
I forgot to put this on.
Yeah, can you do copy and paste so that we can look at it together? Yeah.
Okay.
Just quick copy and paste. Yeah. Okay. Now it makes sense. Now it makes sense. Okay. Okay. Yeah. Don't worry. Will you fix it later? Just put them side by side so we can see them nicely. Yeah. Look at him. He is an artistic. He's an artist. He's an artist. He doesn't want the plots to be misaligned. Okay. Very good. Let me observe this. Now it makes sense. Okay. Distribution of weeks on the chart versus peak on the chart. Okay, repeat to me what is the message that you see from here. Please, go ahead.
So we can see that some songs reach a very high rank quickly but stay on the chart for a shorter time. And others may not reach the very top but remain on the chart for many weeks.
I disagree. You cannot see this from this plot. In order to see this plot, you will have to do this. You take a scatter, listen to me, okay? You take a scatter plot. On the y-axis, you put the peak rank, and on the x-axis, you put the weeks on chart. And then you draw a point which corresponds to each song, so you can see the correlation between the peak rank and the weeks in the chart. Then, if you see two clusters, right, one that it's low and one that it's high, then you can say, oh, then if you see a cluster like this, right, then you can tell me that there are the songs that reach, you can tell me this message. From this plot, you cannot see it. Do you agree with me?
Yes. Oh, yes.
You understand my point, right? Because we don't know. Yeah, it's like you don't know the joint distribution. You're showing me the marginal distribution, but you're not showing the joint distribution. Do you agree?
Oh, yes.
Okay, good. So you cannot tell me this. I believe you, but you cannot tell me this from this plot. Okay?
Okay.
Good. Next.
Next, we visualize the weekly rank trajectories of selected songs, and the figure shows how the rank of each song changed over time. So we can observe different patterns such as rapid breakout hits and long-lasting songs and short-term spikes in popularity.
Jesus. So but look at this. So you're telling me, right, that this Travis Scott song was released in 2017, and then he had another peak in 2025, right? So this song has been around for like 10 years. Okay, whatever, in 5 years. Wow. And what is the other song? Perfect by Ed Sheeran. Jeez, that's a wedding song, right? Look at that.
Oh,
The Shape of You, God damn hate this. No, sorry. Okay, but that song has been overplayed so much. Wow. Okay, good. Wow. So that song has been around for like, wow, for like 5 years. Very nice. Okay, so can I give you a suggestion for this plot?
okay.
So for this plot, you put too many points, okay? Because you see that it's very, very dense. So next time you take your curve and you take out 1 point every 4 and you just plot 1 point every 4. Because I think here you put for every month, right? But of course you can take the average on 1 year and get the average over 1 year, and then you know what I mean, right? So there are it's confusing to see the plot with so many points. Go ahead.
Okay. So finally, we summarize our key findings. First, the charted songs generally have higher popularity scores. And the second is that charted songs tend to have slightly higher energy and danceability. And the third, chart trajectories reveal different patterns of popularity, including short-term hits and long-lasting songs.
Very nice.
Okay, so next is
no, wait a second. Stay there a second. No rush. So, because the popularity in the Spotify dataset just refers to the number of times they were played, right? So this is not connected with the charts. Very good. And chart trajectory show different popularity patterns. Yeah, okay. Very nice. Very nice. Yeah, I was thinking, right, if... Yeah, because you don't have the release date of the song. Yeah. No, I was just wondering about the correlation between the popularity and the charting, right? So if a song it becomes popular first on Spotify and then in the chart, or first in the chart and then in Spotify, I wonder. Yeah. I just wonder about the temporal relationship between the two of them. Okay, very good. Go ahead.
okay, so this is my part, and next we
Go ahead. Who's next guy? Hello. We're missing something, guys. Guys, is it me or?
Yeah, we're finally.
Okay. It's missing. Can somebody take over his part? Can somebody take over? I don't know. We were such a good flow of the presentation. I don't want to interrupt it. Yeah, if somebody can take over, or I don't know. How you guys want to manage?
Or we just go to part 4 first.
Okay. Okay. If you promise me that you come back to these slides, if you promise me that you come back.
Okay. So part 4. Yeah, I think. Okay, guys. So Azure, our level 4 project that went beyond our original data set. At first, I tried to use a Spotify API to get new data, but I got error on it because it now requires a paid premium or something, so
I
I
see.
can use Spotify. So then to fix this, I switched to the Apple iTunes search, and which is free, and so I use iTunes instead. And before doing a big analysis, I first test our new API to make sure it works. So I search for some specific famous artists, and we can see some information like album names, release date, genres, and song prices, and show like this. So just to prove that I successfully read the data. Yeah.
Got it.
Okay. So next. So then I randomly pick 50 songs from our Spotify data set, and then use the API to find their official genres and combine this new genre data with Spotify's balance score, and then which measure how happy song sounds. And so in this chart, we can see the iTunes genres on the bottom, the x-axis, and then the Spotify happiness score on the left. And so this can let us see if a certain music style usually sound happier or more frustrated. And then there's a rank at right.
So my only question is, what is MPB?
Yeah, it's
Because
like it's a kind of Brazil music. Yeah, a music style from Brazil. Yeah.
MPB music. Música popular brasileira.
I don't know how to pronounce it.
Very nice. Música popular brasileira.
Sounds very happy.
Is a trend post-bossa nova, urban popular music in Brazil that revisits typical Brazilian styles such as samba and blah blah blah, baião, with foreign influences including jazz and pop. It's characterized by poetic lyrics, complex rhythms, and intricate melodies. And got them, of course, that's the highest popularity score because there is jazz influences. Okay, very nice. Okay, go ahead.
Okay, so next page.
Can I just say something here? Can I say something here? Can you go back? Because here, even if you didn't plan for it, you also see the popularity. Because since you picked 50 at random, you see that you picked a lot of dance songs. So there's a lot. I wonder why there are so few pop songs, because I assume like 20% of the data set, it's pop songs. So I wonder why you have more dance songs than pop songs when you pick it randomly. But of course, if you repeat the random experiments, you're going to have a different result. So just wondering about that. Go ahead.
Yeah, I think because I just choose 50 songs, so maybe just...
You see rock has 4, right? Rock has 4 dots. Brazilian has 3. How is it possible that the Brazilian music and rock music has the same number of dots? So, but I understand.
Yeah. Okay, so next page. And then I use like machine learning to compare song lyrics with how music sounds. And so I use text block to read the lyrics of 500 songs and give them a sentiment score between positive to -1, and then put this scores on this chart with a music happiness score on the y-axis, and the red trend line shows a very low connection.
Yeah.
It comes at only 0.08, and it is. I think this tells us something interesting. Is that a upbeat dance song can actually have a sad lyrics, and
yeah, I wonder. Did you check the output? I wonder if
yeah.
because you put the whole lyrics inside, right?
Yeah.
And maybe because maybe because the sentiment analysis model, it's probably focused on text, right? But lyrics, they have a certain structure, right? You always repeat the chorus. So I wonder if maybe the model was not trained exactly for this, right? Because maybe the vocabulary,
redundant words or something.
maybe if I had done it right, maybe I would have just looked for the chorus, right? But again, because the sentiment analysis, you just need. Well, because for sentiment analysis, the model usually needs, let's say, only a small sentence, right? If you put a book into a sentiment analysis model, of course, the score is zero because there are positive and negative sentences. So if I had done it, I would have just looked for the chorus and just put the chorus inside, and then got the sentiment analysis from there. Otherwise, I think I would have confused the model.
Oh yeah.
Yeah, you can imagine, right? There is a song is like, "Oh, we fell in love." It's like, "Oh, that's a positive sentiment," and then it goes like, "Oh, he broke up with me and and went with another woman," and then that's a negative sentiment, and so the model will give you zero because there is a balance of sentiments. Go ahead.
Yeah. So that goes like sound alone doesn't tell us the whole story of a song. I think maybe some song have a frustrated lyrics but cheerful melodies or like this.
Mm-hmm.
Yeah, I think my part is not.
Okay, very good. Can we go back to the other slides? I want to say that there is still a part. Did you guys find the guy that was missing? Not yet. Okay, yeah. Somebody tell me about these slides. It's very nice. Oh, you also did PCA. Come on, guys. Somebody tell me about these slides. Guys, please tell me something. Otherwise, I'll start presenting the slides by myself. Because I'm a professor. If I see a slide, I start talking. Whether I know whether I know the slides or not. It's my natural instinct. Yeah. So here you see the correlation. See. No, just stay there. Yeah, we just Somebody tell me, right? Somebody sees the correlation between energy, loudness, and acousticness. And you see that energy and loudness are very much correlated. And that makes sense, right? Because people, loud songs often conveys a lot of energy. That's also how we speak, right? If we want to be very emphatic, we increase our volume. And then here on the left, we see that this is the highest correlation, right? And then there is a negative correlation between acousticness and, God damn it, it should be energy. When you submit the report, please put the features also on the column. Otherwise, it's not clear what is happening. So the strongest negative correlation is between energy and acousticness. Okay, acoustic sounds are usually not energetic. Okay, very good. And the strongest correlation is between loudness and energy. Okay, very good. Okay, go ahead. Next slide. Then you did PCA over the data. So 30% of the axis capture the total variance. So 2 PCA direction already captures a lot. Spotify are concentrated in a dense cluster. This suggests that despite the diversity in music, a huge portion of the tracks share relatively similar core characteristics. Let me give you a suggestion for this plot. Okay, so usually the first 2 dimensions, they really track some average behaviors, right? So let's say the tempo can only vary of this much and whatever. But so sometimes it's nice to disregard the top directions and just look at the, let's say, direction 3 and direction 4, or try to find some cluster on the higher dimension. So when you prepare your final report, try to also look at the correlation, at the scatter plot of, let's say, dimension 2 and 3, 3 and 4, 2 and 4. Try to explore some combination where you can have some other meaningful pattern, right? Because here there is no particular pattern. Yeah. So here you have plotting popularity in terms of PCA1 and PCA2, but yeah, there is no clear pattern here, right? So okay, try to do this experiment. Next slide. We did k-means clustering. Okay, here. Okay, this is a little bit better. Yeah, that's nice. And the cluster center is not visible. The center of the plot is dominated by several large overlapping clusters, orange, light, green, and teal. These likely represent mainstream track songs that follow standard conventions. The orange dot stretching from far down PCA2 axis represent outlier with unique structure, possibly very long tracks and no standard time signatures. Geez, that's nice. That's nice. Okay, same suggestion here. Try to repeat the plot for the top, let's say 5 PCA dimension in different combinations, and see if you see some clusters. Okay, very good. Next slide. Okay, very good. Yeah, can the group leader talk to me a second? Yeah. Hello, group leader, can you talk to me?
Yes.
So how was it working? Was the group too big? Was it hard to divide the work? Did you guys manage to share the code? Tell me a little bit about the experience of working together.
Because we divide the work before we merge the group, so it took a little bit time to communicate how we have to redistribute the work. But I think we work not bad.
Okay. Okay. So you had the same code base, right? You guys worked on the same code base?
Oh, yeah.
Very nice. Very nice. And you were also in my previous class, right? You were in my data science class?
Yes.
That's why you're so good. That's why you're such a good leader, right? Because already you had this experience before, I think. Very good. Okay, very nice. Let's take, guys, a 4 minutes break, right? So we come back at 20 and then we go with group 2, okay? Oh, there's a question. Go ahead.
Is the one-page report the final report, or are they different things?
No, just one. Yeah, just a final report. Yeah.
Oh,
If
so
you
we
want to
have
do
to.
more than one page, it's okay, right? Just
Okay.
no worries. No
Understood.
worries. It doesn't. Let's say maybe one page is minimum, right? So let's say it's a minimum one page.
Okay.
Okay. I'll see you back in 3 minutes. Go walk around, drink some water. Don't sit for too long, okay, guys? We'll already be sitting here for like an hour. Go ahead. I'll see you back in 3 minutes. Very good, guys. Can we have Group B? Can we have Group B? Oh, very good job, Group A, right? Very good job. Can we have Group B? Let me write some comments. 6 members. You did a very good job. You did a very good job. Seems. Can we have Group B? Seems they worked well together. So, one guy missing. Can we have Group B, guys? There should be a Group B. Guys, there's a Group B, right? Let me check. There's a Group B. Oh, there is no Group B, sorry. Okay, Group C. Let's go with Group C. Group C. Very good.
Okay, so we're Group C and we're going to present our challenge 0.
Very good. 5 active, 5 members. Okay, go ahead.
And so here is our basic exploration of this data sets. And we can see like by this distribution of track popularity, we can see that like most of there are lots of tracks that are with lower popularity. And here is the chart of our distribution of audio features. And this chart shows that most of the musics are with less instrumentalness. And I think that this chart really aligns with my daily experience of listening to music. And here's another basic exploration. And the top genres by number of the top genres, all of them have exactly the same 1,000 number of tracks. And here is the danceability by genres. And top 5 genres is of the largest danceability is acoustic, Afrobeat, alt rock, alternative, and ambient.
So can you go back one? So you see that, can you go back to one? So you see here that the number of tracks, it's really 1,000, right? So that's how they compile the data set probably, right? So it's very balanced. So go ahead.
Okay. And here is we explore the artists in our data sets, and we can see like most of the artists have small amount of track, and this is in the normal scale, and this is in the log scale. And our data set shows.
Linkin Park, they have so many tracks. It's surprising. So yeah, they've been active for like less than 10 years. So go ahead.
Okay. So in our data set, the most prolific artist is the Beatles, which have 279 tracks.
Okay, then it's a part of level 3. Next page. Since the original dataset does not contain the date information, we merge another dataset with the date information and combine them with the track ID. So therefore, we can do some decades comparison. And we only have the time range from 2010s and 2020s. So we compare these 2 decades, and we can see that from 2010s to 2020s, there's a rise in popularity and also decrease in danceability. Like
give me a second. So here the date is the release date, right? Is the release date?
It's a date. Yeah, the blue one is 2010s and the orange one is 2020s. Yeah.
Thank you.
Okay, and we
just a second, let me process. So this variance is mood, right? Okay.
Yes.
And so then higher valence means happier mood, correct?
Valence is mostly like the positive energy. We can think of that like that.
Very good.
Yes.
And then danceability is anything. And then okay, can you repeat? Yeah, repeat the message. Sorry, please, because yeah, go ahead.
Okay, and then we want to see which genre dominates each period. So we see that in 2010s the dominant genre are mainly like pop rap, pop dance, dance pop, and EDM. EDM means the electrical dance music. And in 2020s the dominant genre is pops. Okay, next page.
Stay there. Stay there. Stay there. Stay there.
Oh,
Don't
okay,
rush.
okay.
Don't rush. I mean, there is nice. So pop is always the most, but pop rap was more popular than pop in the 2010s.
Yeah.
So you really have never listened to EDM? So if I say Skrillex or Dead Mouse, that doesn't mean anything to you?
I think for me, in these few years, the amount of EDM's music is quite large decrease, I think.
Yeah. So tell me this. You have 3 rows here, okay? Can you tell me which like how did you decide the rows? Can you tell me that?
We have the genre column code genre, and we just like calculate the amount of the tracks.
But how did you choose which one goes in which? Like, how do you choose to put pop and pop rock and pop dance all together?
Because they coincidentally have the same amount of track, and so we just put the same.
I see.
There's some song have multiple genre. Like it's not only classifying the same.
Yeah, I understand.
Yeah.
I understand.
Yeah,
Because,
like this song belong pop rap, but also have pop feature in this song. So yeah.
Got it. I understand. So you did some cluster based on this. Okay.
Yeah.
Okay, very good. Go ahead.
Okay, next page. And we want to see is there any formula for the hit song? So we want to analyze the feature and popularities relationships. And looking at the correlation heat map and the scatter matrix, the answer is not really. Most features like loudness, danceability have a very weak correlation with popularity. All the coefficients are under 0.1. So they're almost like the strong coefficient should lies in 0.7 to 1, but all the coefficient are very small.
So for the plot on the right, the next time do some subsampling. So there are just too many points to see any pattern. So next time just subsample a little bit, right? Otherwise it's hard to see patterns. Do you understand what I mean?
Okay, you mean the too many graph and statistic over here?
Yeah, no, I mean, yeah, the points that you use for the scatter plot are too many. So you don't see the pattern because there are too many, because the points are all on top of each other, right? So you don't see you lose the idea of a density of the plot. So next time just subsample so that you have a clearer plot.
Okay.
And then there is some high correlation right here. So it's
like the high correlation, I think, is like loudness and energy. Yeah, they have high correlation. I think that's relatable.
Yeah. And also acousticness and energy, they have a negative correlation, right?
Yeah.
That's also what we saw from the other guys. Yeah. Okay, go ahead.
Okay, next page. And we want to see the shape of the music space. So we use PCA and K-means for clustering, and we found there are 4 distinct groups. And for example, the cluster 0 is almost consists of the comedy, and like cluster 1 had like mental and grindcore for this cluster. So I believe that this clustering correspond to the type of the music genre and moods. And we can see the PCA chart over here.
Can I tell you something? So this you heard the comment about the other that I did for the other PCA. What I would do is that I will remove. For me, if I see this plot, okay, this plot doesn't show some natural clusters. What I want to see is that I want to see separation between the data. When you run PCA over this data, this PCA does like some pie cutting, right? So the PCA is just cutting the cluster into 3 clusters, okay? So it's not showing me a pattern which I will call a cluster. So try to do this, right? I take the 5 top PCA components and try to find the combination that gives you the best separation, and then you do the cluster in there. You understand my point, right? Here, it's not really a cluster that it's easily identifiable, okay? But I think if you look at some other PCA components, which are not the first 2, it's some combination of some other PCA component, you will see more separated clusters, and that will give you a better result, okay?
Okay.
Makes sense, right? Go ahead.
Yes. Okay, next page. Okay, and we want to compare the charts and non-chart song. The chart song means the songs that appear on the top 200 charts, and in our data set, there are 61 songs belongs to the chart song, and we wanna analyze their feature. So when we compare, then we see that chart song is an orange one here, and they are slightly more danceable, and for energy, they have the much tighter range in energy. Okay, next page. And we also analyze the artist diversity and relationship to the popularity. So we calculate the variance in an artist audio feature and found a slight positive correlation of 0.127. So it suggests that being a more versatile might actually help your career. Next page.
Next is level 4. Okay, next. That's our method. We randomly sample 60 songs from the merged data. Lyrics were retrieved using the lyrics.obhfi, and only 48 songs return valid lyrics. We use the testboard to compute the segment priority, lyrics, word count, and vocabulary richness. The result will compare with popularity and variance. Next. Okay. This feature shows the relationship between lyrics segment and song's popularity. The x-axis is the segment polarity, where higher values means more positive lyrics, and the y-axis is popularity. Overall, the pattern shows only a weak positive relationship. Songs with more positive lyrics are sometimes more popular, but the points are still widely scattered. This means lyrics segment alone cannot strongly explain popularity, and song success likely depends on many other factors.
Can I ask a question? So here, you have 48 songs, right? Did you average the popularity and the sentiment polarity for songs with the same genre?
No, I don't do the average.
Okay.
So
you will have a different points for 2 songs that have the same genre, and I see. I see that because the colors are very close. So it's not clear. It's, you know what I mean, because you have many different genera. So I cannot tell which points belong to the same genre. You know what I mean? Because the colors are very close to each other. Like for
Oh.
example, you know what I mean, right? For example, I don't, because I cannot point. Can you look at there seems to be a cluster, right, of this greenish color, right? And I cannot distinguish between hip hop, pop film, and K-pop, you know, because they are all very close to green. So maybe cut down the number of genre, and so that it's easier to see the difference between the clusters. Okay.
Also, less classes. Okay.
You understand my point, right? So less classes means that
Yeah.
the colors are easier to distinguish, because right now
Since that's too many classes, so it's hard to. Okay.
Just take the top 10 or whatever.
Okay, I got it. And this figures compares lyrics segment with balance, which is Spotify's audio-based measure of how positive or happy a song sounds. The positive chance here is clear than in the previous figures. In general, songs with less positive lyrics also tend to have lower balance. This suggests that lyrical emotion and musical mood are partly consistent, although the relationship is still not perfect.
Good.
Okay, next.
Yeah, as we discussed with the other group, right? Like if you put all the lyrics, you don't know, maybe you have to put only the chorus. So try to see if you can do the modification, right? Maybe you see like a nicer correlation. It seems to be, it seems to be there, right? But maybe if you process the lyrics a little bit, should be easier.
Okay, next.
Okay. Go ahead.
We use the full merge chart dataset to do the chart position dynamic analysis. Songs were grouped by check ID, and we calculate weeks on chart peak rank and weeks to peak and average rank. We plot chart trajectory and analyze their correlation with audio feature and popularity. Next. This figure shows the weekly chart rank trajectories of just top 5 songs.
You know my comment, right? You know my comment. This is too dense, right? You just put like 1 point per quarter, right? Don't put all the charts, otherwise just a blob.
Yes.
And we cannot see anything, right?
The point is too much.
It's too dense, yeah. But let me see. Riptide, that's a classic. All of me, likes all of you. Take me to church, just wake me up when it's all over. What's your favorite? The songs are all very, very popular, yeah? So tell me what's your favorite song, since we cannot see much from the plot. Tell me which song is your favorite. What's your favorite songs between these 5 songs?
If I don't know what the actual songs.
Really?
I don't know. I actually.
They're so famous. Come on.
Some songs I don't know their names, or even I just heard. Sometimes I don't know their names.
Is anybody in the group that can tell me their favorite songs from this slide, please?
I kind of like Take Me to Church.
Come again.
I like Take Me to Church.
Take me to church, another night, say you goodbye. Yeah, it's good. Avicii is very good. I mean, Mr. Brightside is my favorite because it's more rock for me, so I like it more. Mr. Brightside. Okay, very good. So please, make the plot less of a wall of colors next time. It looks like a Jason Pollock painting. Go ahead.
Okay. So Since a smaller chart position makes a better rank, point closer to the top indicates stronger performance. We can see the songs follow different success patterns. Some songs rise quickly and then drop quickly, just like which one? The orange one. Yes. And while others remain on the chart for much longer time. This suggests that the chart success is not only about reaching a high peak, but also about staying on the chart consistently.
Yeah, it's also the rise of social media, right? Now the people have this there's this TikToks. So can you go back? Can you see that there's that song that peaked in 2023? Which song? Can you go back one slide?
Oh.
You see that Take Me to Church, right? As a peak in the 2023. It's probably was in because probably on social media it became famous. And when we were younger, when I was young, you probably were not there. Like they will put a song in a commercial and then it will become a success. And now they put a song in some viral TikTok and then it becomes very popular, right? So it's interesting. Go ahead.
Okay.
Old men talking, it's fun. Go ahead.
This table summarizes the relationships among charts performance measures, audio features, and popularity.
Wow.
Look, curious.
Wait a second. Let me parse this, right? Because it's very dense, right? So,
okay.
A weeks on chart, peak rank, weeks to peak, okay? Then stability, energy, balance, tempo, and popularity. So, let's see. Peak rank and weeks on rank is very high correlated, very good. Weeks to peak, right? Is how many weeks? So the thing is that, so the interesting thing is that the peak rank and the weeks to peak, they are not correlated, right?
Yeah.
So you cannot say, yeah, go ahead.
Okay. So this result is that songs with more weeks on chart usually achieve better peak ranks. Popularity is also linked to better peak rank and longer chart durations. In contrast, audio features such as danceability, energy, and balance shows only weak relationship with chart performance. This means no single audio features can strongly explain why a song becomes successful.
Like it.
Okay.
And next is the challenge questions. And the artists who focus on a consistent musical style will develop a strong brand identity, and this may help them achieve greater popularity. And our data set shows that highly popular artists actually exhibit relative low diversity in their audio features. And here is the genre with the highest average popularity is the pop film genre. But since the dataset does not contain the information about the number of strings per track or whether a track appeared in the top 200 chart, so the code cannot directly analyze the average popularity based on those conditions. But the code performed an analysis by considering only tracks with the popularity score over 70 to see if the genre with the highest average popularity changes. And this gives an indication of how popularity change is for high popular tracks within the datasets. And the genre with highest average high popularity for tracks with higher popularity is the club genre.
Okay.
And here is the Beatles are the most prolific artists in our dataset as the previous shown. And here this chart discusses the different audio features that prolific and less prolific artists shown, and we can see that for highly prolific artists, it both shows the like lower visibility and lower popularity, which is very different from the less prolific artists.
Yeah, let me suck this in a second. Let me suck this in. So standardized audio features. So these are standardized. So you standardize everything to one. So that's good, right? Then you have a standard deviation from the mean. And really, the separation is so clear. Wow. So the blue is the less the blue is the high prolific. So this is variation from the mean, right? And then you tell me standard deviation from the mean. Okay. So this is because explain this to me, right? So look at the popularity, right? So the popularity should indicate no, because because if a artist is highly prolific, then should also be very popular, right? Otherwise, people would just not publish their songs. And you see that the most prolific artists are like the Beatles, right? So they're also very, very popular. So you have a negative variation from the mean. But this should be in the direction of being more popular, right? Standard deviation from the mean. So what does it mean that you have a negative standard deviation from the mean?
My understanding of like this popularity will be like maybe the highly prolific artists, the less prolific artists like spend more time on their one songs or their one music. So once they upload their music, they are like many that are more popular.
But you see that also instrumentedness, right? This is for instrumental songs. And I think that just there are so few instrumental songs, right? And you're telling me that highly prolific artists have higher instrumentedness, whatever. I think please check your data. It's there's something a bit fishy. Yeah, something a bit fishy. You understand what I mean, right? It's yeah. Either there is some. It seems that there is some flipping going on, right? It should be the other way around. Yeah. Also, the difference in densability. Yeah, they should be more. It should be more dense. Yeah, it seems that there is some. Like I don't understand which way it means that one is greater than the other. Yeah, it seems that there is something not obvious. Go ahead.
Okay.
Then the question 3 is which audio feature are strongly correlated with popularity, which is also discussed in the level 3. So just as I mentioned, now the feature is highly correlated with the popularity, like the coefficient are all less than 0.1. Okay, and another question is, are there surprising negative correlations? I think yes, like the acousticness and valence. Like in my opinions, like acousticness, the more acousticness and or more valence music should be more popular in my opinion. But surprisingly, I found that there are a negative correlation with the popularity. Okay, and like speechiness, instrumentalness, liveness are also in negative correlation, but that's kind of reasonable. Okay, next page. And The question 4 is, over time, are songs become faster, more danceable, or more happy, which is balance. And we can see the blue line is the tempo, green line is the danceability, and red line is the balance. We can see the tempo is gradually increasing in the very fast pattern. Isn't that the songs are getting more faster? But for the danceability are always high, but just a little drop in last year, 2023. And for balance,
That's
is
3 years ago. That's 3 years ago. It's not
yeah,
last
that's
year.
3 years ago. Yeah,
I wish it was 2023. Trust me.
I found out. Yeah, 2023. And balance, there's a kind of low, but there's also a drop in 2023. So I can tell like maybe the
COVID.
people in 2023 is unlikely to dance and are not happy. Maybe they're
But those are the COVID years, right? Because we're COVID in
yeah,
2022, so
maybe
probably that's why.
yeah, that maybe that's why. Okay, next page. And the question 5 is, do charting songs have distinct audio feature profile? Like the charting song is the songs in the top 200. And we analyze this feature in danceability, energy, balance, loudness, and tempo. So we can see they're almost the same. So maybe, yeah, okay, there's no distinct feature difference. Okay, next page. Oh, this is a last page.
You don't even have a thank you page or a summary page or, yeah? Gosh, guys. Okay, well, can the leader talk to me? Tell me how you guys worked, how it was, if everybody was responsive, and so on and so forth. Yeah.
First when we like when everybody first meet in the line group, like someone have already almost finished the coding part, and we distribute the work and we discuss our report presentation last night. Yes.
Last night. Okay, good.
Yeah.
Always last moment, students. So you discussed online or you met physically?
Online.
Yeah. Try to meet physically, guys. Try to meet physically sometimes. You know, I think your generation is. Okay, very good. Thank you so much. Okay, so let's hear it from Group C.
Oh, we are Group C.
Oh, you're right. Group D. Sorry, guys. My brain is Group C. Let's hear it from Group D. Group D. Everything is okay. And Group C. Sorry, goddammit. Group D. Oh, Group D. Go ahead.
I'll share my screen.
Yeah, so the person is sharing before, if they can stop sharing. Hello, can you stop sharing? Who's sharing? Yeah.
We have Group C, and this analysis is we have to analyze 10,000 Spotify tracks across 140 genres, and we start with basic statistics, then move to temporal trends, clustering, and finally prediction models. Think of it as a journey plan. What does the TikTok look like? Can we predict what makes a song popular? The level 1, what we did is we log the data and clean it and look at distributions.
Mm-hmm. Mm-hmm.
And as you can see, here's the two dots of the popularity. The left shows that the track counts by popularity bins. Each bin has 10 points. Sorry. Yes. 0 to 9 and 10 to 90 classification. So the 0 to 9 bin is the largest. They're also high in 20 to 59, and then they decline after that. There's very few tracks are 80 to 99, down in 90 to 99. Right is the full popularity distribution. There's a very large spike at 0. So most of the tracks are not popularity at all. So it's a left skewed graph.
Okay.
Okay, so next one is audio future distributors. We have 9 classifications: density, energy, and etc. I want to 那个叫什么强调yes many futures are non-normal and several are strongly rise to like numbers and energy, and density is a little bit. And this one is top 10 genres by number of tracks. Wait a minute.
Yeah, I mean, we have seen this plot, right? So you're the last group, so we have already seen these plots. So
okay, so this one is top 20 most prolific artists. The Beatles is a most. They have the most tracks in history. And this is the 5 horizontal park plus panels. And there are sorry. So the pattern is progressive house and the lower pop look highest in energy. Acoustic looks highest in acousticness. Pop and indie pop are mid to high disability. Tempo centers on mostly around about 100 and 150 BPM with some outliers. Hence, diversified by genre, but with overlap. So overall distributions differ by genre, but there is still noticeable overlap.
Okay.
This is a correlation heat map title. Correlation heat map for audio features and popularity. So popularity has very weak correlation with most audio features. And there is some strong feature relationships like energy and loudness. And energy acousticness and loudness and acousticness and disability of mass. So the plot suggests all audio features correlate with each other more than they correlate with other. So the next one is level 2. The first one is the average popularity by years.
So this is the track count per year, right? So there is something. So you're saying that most of the dataset was released in 2022?
Yeah, yes.
No, but because the whole data set is 100,000, whatever. And here your highest track count is 3,000. So there is something, you understand there is something fishy here, right? Are you sure?
Yeah, maybe we have introduced some, but our data set is not the right one. So maybe it's a
Maybe you just kept some top something, or yeah, it's kind of strange. Yeah, this one here looks also this one here. Yeah, but why would your popularity drop to 0 in 2023?
The data set list is the 220 and 223 22 data set.
Yeah.
Most of the data are in this year, so it's weird. I don't know.
Yeah, there is something. Yeah, because you saw for the other group that the popularity actually remains kind of stable, right? And also the popularity became less noisy. Yeah, there's something like the data set is not balanced. It's mostly 2022 data. No worries. Go ahead. No worries.
Okay, this is the number average popularity by years. It's a very low values appear early decades and again around the most recent years. So the present chart has a strong outlier year that likely dominates the trends.
Yeah.
Okay, this is
okay. Yeah.
This is pop and versus pop and versus classical. Comparing 5 genres: growth, popularity, danceability, energy, balance, and acousticsness. And we can see that hip-hop and pop are generally higher in danceability and energy. And classical is much higher in acousticness and lower in energy. And the balance and popularity show overlap across genres, but with different distribution shapes.
Very good.
It is a 6-panel box glass speaker titled Audio Features Charted and versus non-charted tracks. Through sensitivities, energy, balance, speechness, and acoustics, and tempo. Charted tracks look generally more danceable.
Yeah.
And slightly higher in balance.
Right, nice.
Acoustics appear lower for.
No, but the one there, I think, because the scores are very, very low there, right? So it's like because because basically the acousticness is always going to be very, very low, right? You see that the speechiness and the acousticness, they are not really relevant because there are so many outliers. You see that they are all outliers. So it's just random there. Yeah.
The energy and tempo are fairly close between groups.
And we saw it also on the other group, right? That they did the distribution of the energy, and you can see that the energy of the charted is tighter. So this part is good. Yeah, nice.
And switching is low for both with many outliers. This is audio features versus popularity.
Yeah, this is too hard to read, right? So as I said to other groups, you really have to subsample because it's very hard to see any pattern. Yeah, just randomness.
And the highest are is loudness versus popularity. Yeah, so the point clouds are very diffuse, so the image suggests very weak linear relationships between individual audio features and popularity.
Yeah, also tempo and popularity, there is some pattern there, but it's just very hard to see.
And the lowest R is occurs in liveness. Sorry, speechless.
Very good. Okay, yeah, this is the same comment as for the other group, right? Try to look at not the first PCA dimension, but other smaller, other lower rank PCA dimension. There is really no pattern here. And also here you have, there is no clear pattern here, right? So on the left hand side, you have how many? So on the left hand side, you also have too many clusters. You selected 1, 2, 3, 4. Anyway, so you have 10 clusters on the left, which is too many clusters, right? So it's just there is no pattern there. It's just noise. Yeah.
Okay.
So try to redo picking some other PCA dimension. Just drop the first two, look at the combination of the others, as we saw for the other group. Go ahead.
It has we have too many labels.
This is better. Yeah.
And this is the horizontal bar chart title, name, auto features, charted versus non-charted.
Yeah, so this is the comment as for the other group, right? Because the tempo has a different support. So you have to bring down the support to be normalized between 0 and 1, so you can see it better. But yeah, basically there is because it's hard to see the other features. Yeah. So try to fix this by normalizing the features. Yeah.
Okay. The level 4 is deep learning and external data part. So this is the top 15 genres by average popularity. So we can know that the highest genres is pop film and K-pop and chill. And most values are roughly 45 to 60 range.
Very nice. And this is the popularity. Right, to see if again, this is dominated by the popularity, right? Because these are all very prolific and very popular artists. So maybe remove the popularity so it's easier to see the other features, right?
Okay.
And this is the correlation coefficient that we saw before. Yeah.
Blue bars are positive correlations and red bars are negative correlations. Stronger positives show loudness the strong indication is as instruments.
Yeah, you see that this is also not consistent with the other groups, right? You see that the other groups, they had that the tempo was always increasing, right? But here you don't have the same pattern. So I think you need to check your data set. I think something weird happened. So this is just very noisy, right?
Yeah.
Do you agree that the other groups, they have a very clear increase of tempo over time, right?
Yes.
So yeah, try to check your data set. I think there must be something wrong there. Yeah.
The charted versus non-charted. The charted tracks appear generally more danceable and slightly louder, less instrumental. The non-charted tracks show widespread instrumentals and customers, more extreme tales, especially instrumental and acoustic heavy songs.
Very good.
However, the applause just chart success is more associated with danceability plus loudness plus low instrumentalness than with tempo low.
Very good.
Okay, this is.
Oh, you did the mode. Okay, you checked the mode. Okay.
Yeah, the key mode has only a small effect on popularity.
I mean, because it's not the correct way, right? Because you should check the mode versus for example, the mode versus the danceability. Then you expect that the minor modes, they are not danceable, right? And the major modes are danceable. This is not relevant because basically the key and if you just look at the distribution of keys in major and minor, then they should be uniform. You have to correlate the danceability with the key. You understand my point?
Yeah. Yes, I understand. Okay, this is a bar chart comparing version model errors for popularity prediction. The random forest performs the best. The linear regression performs the worst. KNN is in the middle. Better than linear regression, but clearly worse than random forest. For this data set, linear ensemble models captures popularity patterns better than the linear baseline and KNN.
This one here we cite. This one here is good. Yeah, this one here is good.
This is a pairwise scatter matrix for popularity, danceability, energy, balance, and tempo. And audio features relate to each other more clearly than they relate to popularity. And popularity appears influences by factors beyond these 5 features alone. A few boundary points are present in these plots.
Very good.
Okay, this is a density plots share. Yeah, hip hop. Sorry, the classical music is.
Of course. The energy, yeah.
Those energy that are
very low.
And I want to make some final words. A great song alone doesn't guarantee streaming success. Its artist reputation and their marketing budget and algorithm make discovery and a bit of luck. Audio engineering matters. You can succeed with better production, but it's necessary, not sufficient. In my opinion, for future Spotify success, we have to optimize the danceability targeting clouds and radio. And then the second is clean production. The third is general appropriate features like classical can be low energy and the hip-hop should have punch. And the fourth is invest in equality in artist brand and playlist placements. This is the end of my presentation. Thank you.
Very good. But what about the other members of the group? What happened to the other members? You were alone?
Yes, I thought that I had to do the presentation myself. So
no, but I mean, you are assigned to a group, right? Did you talk to the other people in the group?
We finished the code together.
No, but I mean, next time everybody has to talk, okay? So how many people were active?
6.
No, but we say clearly, right? Everybody has to talk during the presentation, okay? So next time everybody has to present, okay? It was very clearly stated everywhere in the class, right? So that's yeah. And also, you didn't do the sentiment analysis, so try to see if you can put that in the final report. Yeah. So okay, so now you understand, right? You saw the other two groups, right? So the other two groups did a good job. So you know what to expect. You know what you have to deliver for next time. Okay.
Okay.
Okay. Very good. Okay. Now we have a presentation on a movie on Umberto D. There is student volunteer to deliver. Please go ahead. Yeah, you can stop sharing. Yeah.
So I should go straight.
Yeah. Go ahead.
Okay. Okay.
Yeah, go ahead.
Please
Let's
wait.
enjoy the presentation. Yeah, can you stop sharing group D?
Let me see.
So we can relax, huh?
Can you guys see the screen?
Yeah.
All right. So okay. Oops. How do I close this?
Yeah, you can close it. You can close it. You can close it. Yeah.
Okay. So because I didn't do much in our group work of the homework one, so I decided to share this movie that the professor mentioned last time with you. And I saw this was a homework, but seems that it wasn't. So all right. Today I'm going to talk about the aesthetic of the poverty and dignity, the setting the discuss on budget D. And let's talk about the background. The director is Desika, and the film, the era and the location of the film was post-World War II Italy. You know, during the World War II, Italy was one of the fascist regions. So after the war, they have a long period marked by the severe economic depression and a hyperinflation. And the movie is very special because it moved away from the artificial cinema and confront the raw, unpolished truth of the human condition. This is very different from the previous movie they made in the 1930s and the 1940s. And it is widely regarded as the peak and the elegy of the Italian neorealism. 就是说，它是这个概念的最高点，也算是这个时间的一个结尾。Okay, so I will talk about the word later about this. So let's take a brief review of the plot. The main character is an old man, and he is a retired servant. And living on a pension, he faces a cold-blooded eviction from his landlady. So he has to sell his belongings, like his watch, his books, but his pride is too deep to stop him from the begging. And his only bonds are with the flick. That was his dog, and Maria, a young man facing her own crisis of an unwanted pregnancy. and it reflects the society that had no room for the vulnerables. So when Umberto returns from the hospital after a fever, he finds that his room was demolished and his dog was missing. And he lost all his hope. After rescuing Flick from the government's pound, 就是那个狗狗的那个看护所, he takes the dog to every place he expected to find a new home for it. Yet after being rejected everywhere, he chose to end both of their lives on the railway tracks to die with dignity together. However, Flick's desperate struggle to escape from the oncoming track wakes him up. In the end, they play together in a park, though the poverty remains. 就是说，他们到最后这个问题还是没有解决，他们还是很穷，但是至少他们还是快快乐乐的在一起玩耍。Okay, let's talk about the art design of the movie. First, the on-location shooting is very special because it is filmed on the real streets, a dog shelter, and actual boarding houses of Rome. It used natural lighting to create a gritty documentary-like atmosphere, just like the documentary. And they didn't choose the professional actors. Like the Umberto, the main character, was played by the 70-year-old linguistic professor. So by using everyday people instead of movie stars, the director captured raw, unpolished, and authentic human reactions. Also, the camera lingers on tedious everyday tasks. It is called the dead time and the long takes. A famous example is a long sequence in which Maria slowly wakes up and makes coffee. This technique forces the audience to watch and to feel the heavy, unfiltered passage of time in poverty. And the last one is the objective camera. Using mostly eye-level shots, camera acts as a calm observer. It refuses to use dramatic angles to artificially manipulate the audience emotions. Here we can see that the film is filmed on the streets and the camera is mostly eye level with the characters. And here I'm going to talk about what is the Italian neorealism. To trace back to the 1930s and 1940s, the Italian may call that the 20 years. During the fascist era, cinema was heavily controlled by Mussolini's regime, and the cinema is dominated by light-hearted comedies and upper-class romance shot in the luxurious studios. They want the people to enjoy the how do I say that? They want to only to look at the bright side of the society instead of the poverty and the harsh reality of the fascist rule. So after the World War II, Italy was left with destroyed infrastructure and massive unemployment. So the Cinecittà studios was, as they were occupied by refugees, the filmmakers have nowhere to shoot their fancy movies. So they have to shoot outside and face the real world. The directors feel a strong moral urge to reject the fascist illusions and document the true collective suffering from the Italian people. And that is the so-called neorealism. The key elements of the movie is on-location filming, non-professional actor, long take, and critics of the government and society, and dramatized moments. And the last one, the open endings. These are very special features. Like it's almost like the documentary. There are no happy endings, no happy plot. There are just people living their lives. Here we can do a little comparison. This is a movie filmed in the 1930s, the Il Signor Mix. You can see that the man has fallen in love with another wealthy snob, and he wants to pursue her. He wants to get her love, but by pretending to be another man. So a series of humorous misunderstandings will occur before the things are cleared up. This is not a very special movie, but I put it here is because the main character was played by Desika. I mean, the director of the movie. So what changed the Desika? You can see that it was the destruction of World War II and the cruel social reality. This made him to take off his fancy suit, move the camera away from the fake studios and point it at the ordinary people. He became the conscience of the new realism. However, this kind of art was critiqued by the government because it shows the poor side of the newly established Italy. So the new realism was not that long, wasn't a long period because after the 1950, the economy gets better and the governments don't want you to talk about those bad things. You know, every government do that. So let's take a quick look of the Desika's works. We have Umberto D, Two Woman, or the final. I forgot the third one or the third one, and the fourth one is very fast. It's very famous, called the Bicycle 6. They are all. I haven't watched all of them, but they are very good movies, and you should give them a try. Oh, so in the end, let's conclude with Umberto D. Just like the image of Umberto D and Flick walking in the park, this film does not give us a Hollywood miracle ending. Poverty remains, and tomorrow is still very hot. But Umberto chooses to live on with dignity for the sake of his own companion. And this film it's not just only the ultimate masterpiece of neo-realistic aesthetics, but it was also too real for the Italian government, who desperately wanted to forget the pen. So thanks for your listening. This is my presentation for the movie and the neo-realism. Okay.
Thank you so much. Please share the slides in Slack so that we can all enjoy them.
Okay.
And let's pick somebody else for a movie review for next week. Let's see if there are any reviews, any volunteers for the next week's movie review. Let's see if we have a volunteer. I'll suggest a movie and you guys do a review, and then we discuss it in class before the ending of class. Okay, guys? So we can all do something fun together. Otherwise, I think class would be too boring. If there is no volunteers, then I pick a volunteer, okay? This is a mandatory assignment, okay? It's a mandatory assignment. Okay, very good, guys. Thank you so much. I think for today, we stop here. It was a very, very good class. I really like a group 1 and group 2. Group 3, you guys need to improve a little bit, especially I want to see everybody talk and prepare a nice presentation. So now the TA will open the submission. So Friday, you submit your material, and I will release the new challenge on Friday, which is going to be your first deep neural network. And otherwise, thank you so much for your time, and we see you next time. Okay, guys? I'm going to mute myself. I'm going to be here for a few minutes if you have any questions. Otherwise, we talk soon. Huh? It was a very good class, and I enjoyed not talking and just asking questions and bothering you people. Okay? I want to volunteer for next week. Okay? If you don't volunteer, then I'm going to choose somebody, and it's a mandatory assignment. Okay? Ciao, guys.
Ciao.
Bye-bye.
Bye.
Teacher, can you hear me? Professor,
Yeah.
can you hear me? I think we may be forgotten.
Which are you? You're another group?
Where is the Google? Where's the Excel file?
Group? Your group? We did
there's
ABCD, right?
Because so many people drop your classes, so you basically just assign every classmate to another group, right? But
Yeah, correct.
but we still have because last time our member doesn't they didn't drop the class, so we keep our group, and you didn't reassign us to another groups, so we just like keep the group, but the new list we didn't see our names on the list.
Okay, so when you say we, how many people are we talking about?
There's
Five people.
Five people.
So okay,
Yeah.
guys, go to the file, right? Go to this file is an edit file, okay? So go to the file. Go to the file with the groups, right? You have the group, right? I shared in the chat, right?
Can you post the link one more time?
It should be here. Oh, so we listen to you guys next time. No problem. No problem. Okay.
Next.
So links, yeah. Of course. Because today we already like 2 hours of presentation. I think it's very heavy. Yeah, is this link here?
We are group C in the upper part.
Yeah. Okay. So put yourself in group B now for me, and then next time you guys present. Okay. You put yourself here. Okay. So you're 5 people. Gosh. Okay. Next time. Okay. Very good. Put yourself here. Put yourself here now, okay? So that when we do the group for challenge 1, then we know that you guys are there, okay? Is that okay with you guys?
I'm okay.
Okay, very good. Yeah, sorry about that because I just had many people drop, but we listen to you guys next time. I think for this time we're all brain dead. Yeah, I mean I'm brain dead. Like criticizing, staying focused on all the slides of the presentation and like giving pointed comments. It's very tiring, so I cannot do another group. But we do next time. No problem. Is that okay? Can you fill in this form now before you guys go? So when we do group 1, we have the names.
I think we don't have the access to edit it now. Somehow the access has turned to comment only.
Very good. So just write it in Slack, please. Write the groups in Slack, and because the TA is the owner of the file, it's not me. So I have to ask the owner. I have asked now file to share. So just write it in Slack, and then I'll put it in the file when Naufal gives me access. Okay.
Okay.
So let me write now. I'll write now. Just a second. I'll do this. Group E. And I say new.
Probably
here.
Group H is the same. Is in the same situation as
Group H. Who is Group H? There is also Group H. Okay. So there is also Group H. Okay, very good. Group H. Okay, Group H. So we do the other groups next time. Very nice. Group H. New. Post your names here. Oh, very good. So that's what we do next time. No problem. Now file add to the sheet. Now file add to the sheet. Okay, guys. No problem. Okay, next time, first round is always a little bit messy, right? Because you saw how many people left. So group H, you are also 5 people, right? Group H. Can group H talk to me? Group H. Group H. Can you guys tell me what is happening? So we have 5 people from group B, right? So we have 4 group with 5 people per group. It's 20 people, and that should be the number of people in the class. Can you say, can group H, is really group H in the same condition? Can you guys tell me? Because the names are different, so they didn't get shuffled. Also, is there anyone that is not been assigned to a group and it's not in this new group B? Okay, I assume. Okay, so next time we'll fix the problem. Okay. Well, wait a second. If somebody wants to tell me something, I'm here. Otherwise, Group B, please put your names in Group B. Put your name here, and then next time we add you to the sheet. Okay. Any more comments, guys? Otherwise, okay, good. Otherwise, I need a volunteer for the next movie review. Huh? Okay. So there is, okay. We have 2 people in Group B, and Group H still nothing, right? Ah, very good. Very good. We have all the names. 1, 2, 3, 4, 5. Very good. So Group H, let's see what's happening with Group H. Thank you for your help again, guys. Sorry for the confusion, but it's okay. We just do it next time. And actually, I prefer it that way. So you have more time to talk. Otherwise, we will have to rush. Okay. Okay. Very good, guys. I'm gonna be here a little bit more, right? If you want to ask something. I'm gonna be here a little bit if you have anything. I'm looking for a movie to review for next time. I think it's a very good idea. I'm looking for a movie. La Ciociara. Okay, guys. Okay, guys. I am going on with my day, and we start the recording now, and then we fix the groups next time. Okay, guys. Ciao, guys.